All right, so we're going to be talking about integer exponents. This is the first concept. We're going to talk about things you'll see in all four practices today. So, properties for powers. It's easiest to see if we rewrite our powers as repeating multiplication. So let's talk about the first page, powers with the same base. If I have my example is 7 to the 4th power times 7 to the 2nd power. Now, I know we've talked about this before. It's been a while since we were in the classroom, so not too sad if you don't remember. But how do I rewrite 7 to the 4th power? Well, I know this tells me I'm multiplying 7 by itself 4 times. So 7 to the 4th power becomes 7 times 7 times 7 times 7 and then this 7 to the 2nd power, it's going to look really similar. It's going to be 7 times 7. We'll see our 7 appear twice. And now you can see something. Well, this is just multiplication. So I've got 7 times 7 times 7 times 7 times 7 times 7. And we can just rewrite this as all of those 7s multiplied together with no separation in the middle. Now, how many 7s do I have? 1, 2, 3, 4, 5, 6. So our answer is 7 multiplied by itself 6 times. This is the addition property, because if I've got 7 to the 4th times 7 to the 2nd power, that's the same as 7 to the power of 4 plus 2. All right, 7 to the 6th power. If you're having a hard time, if you're getting the wrong answer, break it down, write out that repeated addition. All right, and so this was our property of addition. Well, we've got another one that's going to look a little bit like this. Let's say I've got 2 to the 3rd power, and all of this I have to the 4th power. I can still write that as my repeated multiplication, but I've got to remember all of this is what's being raised to the 4th power. So that's 2 to the 3rd power times 2 to the 3rd power times 2 to the 3rd power times 2 to the 3rd power. 1, 2, 3, 4, okay? And now each one of these is 2 times 2 times 2, 2 times 2 times 2, 2 times 2 times 2, 2 times 2 times 2. And each of those is being multiplied together. So now, once again, I've got just a bunch of 2's, and I can write it like I wrote this with all of those. 1, 2, 3 multiplied in a row, and I end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 2 to the 12th power. How else could we have gotten this? Well, I see I've got 2 times itself 3 times, and I do that 4 times. 3 times 4. Sorry. I'll write this properly. 2 to the 3rd power to the 4th power is equal to 2 to the power of 3 times 4, which is equal to 2 to the 12th power. Guess what we call this? Multiplication. All right, and there's one last property that we need to go over for the same base. And that's when we have something that looks like this. 6 to the 2nd power. Oh no. Sorry. So it looks like this. 5 to the 3rd power. And like 13th power over 5 to the 7th power. Now, what do you think I'm going to have you do? We're going to do the exact same thing we've been doing. And I'm going to have how many on top? 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. If you need to slow this down or pause the video to take notes, feel free. We had 13 on the top, 1, 2, 3, 4, 5, 6, 7 on the bottom. And now this trick, we have talked about this before, I promise. Since all these are multiplied together, these are these are all my factors for what's on the top and what's on the bottom. And I can cancel out common factors from the top and the bottom. What I mean is, I can look and say, okay, I've got a 5 on top and 5 on the bottom, and I am going to cancel those out because 5 divided by 5 is 1. Not 0. 5 divided by 5 is 1. All right? And I can do that with every 5 that's on the bottom. So that's 4, 5, 6, 7, 5's canceled out from the top. And I am left with 1, 2, 3, 4, 5, 6. And remember, this is not 0. We canceled all of these out because this is 1 times 1 times 1 times 1 times 1 times blah, 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 blah. So I've got 1 on the bottom, 4, 5, 6, and 5 to the 6th power on top. All right, and this is where we gets a little bit tricky. Five to the 13th, or 5 to the 7th. We can also write this as 5 to the power of 13 minus 7. We're going to get to cancel out everything on the bottom. Is equal to 5 to the 6th power. And a quick note, if I have 5 to the 7th over 5 to the 13th, I still do top minus the bottom. In this case, my answer would come out negative. And what happens with negative is I have to flip that to being on the bottom. Because I've got 0 5s on the top. All right, and this one I know I've driven home. What is anything to the 0 power?